Welcome to the class of statistics for the class 12th English medium part 1 chapter 2 linear correlation by Vitan sir. In today's tutorial we will be studying how to convert a numerical data into a rank data and how to break the ties between the ranks. Starting with illustration 20 of a simple sum. In this question, 8 students and their marks in the statistics and accountancy are given. So basically a numerical data is available. The statistics is considered X and accountancy is considered Y. We have to calculate the rank correlation coefficient between the marks of statistics and the marks of accountancy. Now n is equal to 8. We will start by writing down the basic data here. The roll numbers are 1 to 8. The headings you will be giving statistics accountancy. For statistics, the original marks and its rank. For accountancy, original marks and its ranks. We will write down the question first. The marks of statistics and marks of accountancy. Now we will start with the marks of statistics. If you check the data, the highest marks in statistics are 98. So we will give it rank 1. The next highest mark are 90, that would be rank 2. The next highest mark are 82, so that would be 3. And likewise, we will assign the ranks to 78, 4, 75, 5, 62, 6, 36, 7 and 25, 8th rank. Similarly, we will assign ranks to accountancy. The highest marks in accountancy is 91. The next is 86, the next is 84, the next is 68, 62, 60, 55, 51. So now we have got our two columns Rx and Ry, and then we know what to do. Start by writing down two columns D and D square. D is the difference of the ranks. Difference of the ranks of Rx and Ry, they would be like this. You have to make a difference of the two columns that you have already studied in the previous tutorial. After finding the difference, make a square. After getting the square of the differences, make a total of the differences and the squares, and that way you are ready to move on. Write down the formula 1 minus 6 summation d square upon n into n square minus 1. 1 minus 6 into 12 upon 8 into 64 minus 1, because 12 is the total of the squares of the differences of the ranks. Moving on with the formula, multiply, divide, subtract, you will get the answer 0.86. So we can say that the value of R is closer to 1 and there is a high degree of positive correlation between the ranks obtained from the marks of statistics and the marks of accountancy. Now, in case there are tie in the observations, means the observations are equal. Two of the students got 90 marks in statistics, or three of the students got 50 marks in accountancy. What to do then? How to give ranks to them? Who will get the first rank? Who will get the next rank? When the values of the observations are same, there is a problem in assigning ranks to such observations, and at that time we can say that there is a tie in the observations. At that time we take an average of the ranks to be assigned to such observations. We will take an example for that. For example, these are the observations available: 37, 60, 42, 78, 42, 50, 66, 42, 60. Now the first rank will be assigned to 78. Naturally 78 will get the first rank. Now once 78 gets the first rank, the next rank is received by 66. Now the next should be given to 60, but as you can see there are two 60s here. So the ranks are 3 and 4. Now which should get 3 and which should get 4? No. What we are going to do is find the average of these two ranks 3 and 4. That is 3 plus 4 upon 2 equals 3.5. So we will assign 3.5 and 3.5 to both these values. Did you get it, guys? Plus the ranks divided by number of ranks, whatever the answer, we will assign them to both the values. Now next is 50. We will assign the fifth rank because third and fourth are over. The next is fifth. After fifth comes the sixth rank. But 42, 42, 42 thrice it is. That is 6, 7 and 8. So we will do 6 plus 7 plus 8 divide by 3. The answer is 7. We will assign 7 to all the three values. We will not assign 6, 7, 8. We will not assign 6, but we will assign the average of the three. The average of the three ranks is 7. So we will assign the rank 7 to all the three values. Are you getting my point here? We will assign the same rank to all the three values, and that rank will be the average of the three supposedly to be assigned ranks. The remaining rank is not 8, but 6, 7, 8 are done. So the remaining rank is 9. So that way we will be assigning the ranks to each and every observation. Now, whenever we are assigning, whenever we are breaking the ties, there is a correction here because we are not giving them the actual ranks. We are giving them an average rank. Because we are giving them an average rank, we have to make some corrections in our final answer. And that correction done is known as correction factor CF. CF is to be found as m cube minus m upon 12. Now this is a fixed formula. 12 is a constant value. It will not change. M cube minus m upon 12. This answer will be added to the summation d square which we get from our regular table. In this formula m cube minus m upon 12, m is the number of times an observation is repeated. That means, for example, in this observation 60 is repeated twice. So m will be 2. 42 is repeated thrice. So m will be 3. So 3 cube minus 3 upon 12. 2 cube minus 2 upon 12. Whatever the answer, we will make a total of those answers and we will add that into our summation d square. Let's see how. The formula for that tiebreaker will be 1 minus 6 brackets summation d square plus cf upon n into n square minus 1. You see, only one cf has been added into formula. Everything else is same. So for you will not multiply 6 directly with d square, but you will add cf first and then multiply the answer with the 6. Remember that if you make a mistake here, your answer will be wrong. Here CF is summation, sum of whatever number of ties are there. Find CF for each and every tie individually and then make a total. So summation m cube minus m upon 12, where m is the number of observations. Let us start with an illustration 22. Here marks in economics and marks in dancing skill for 8 students are given. The marks in economics and the marks in dancing skills. And we have to check whether there is what kind of rank correlation there is between them. We are using the Spearman's method. Now first of all, check out the economics. In economics, the data is 60, 30, 10, 20, 30, 50, 30, 40. You can see here that 30 is repeated 1, 2 and 3 times. So there would be a correction factor here. We will calculate the correction factor first and then we will continue with the final answer, but we will calculate the correction factor first. So in economics 30 has been repeated thrice, while in dancing skill 80, 20, 60, 40, 12, 28, 20, 15, 20, as you can see, has been repeated twice. So what we are going to do, first write down these columns, the observations which have been repeated, number of times they have been repeated and its correction factor value. The first observation is 30 which has been repeated 3 times. So its correction factor value is 3 cube minus 3 upon 12. Now 3 cube is 3 3s are 9 3s are 27. Minus 3 is 24 divided by 12 is 2. So correction factor for observation 30 is 2. Next observation was 20 for which twice it has been repeated. So the correction factor is 2 cube minus 2 upon 12. 2 cube is 8 minus 2 is 6 upon 12 is 0.5. So only these two corrections are there because only these two observations have been repeated. So we will make a total. The total correction factor will be 2.5. So in the final formula, whenever we will be calculating the correlation coefficient in the summation d square, we will add 2.5. Write down the headings like this: marks in economics, that is X, its rank; marks in dancing skill, that is Y, its rank. Write down the question as it is: marks in economics and the marks in dancing skill. Once you are done with that, we have to start by giving ranks. For marks in economics, the first rank should be given to 60. That's the first rank, highest marks. The second rank is 50. Now the third rank is 40. After 40, as you can see, the next is 30. 30 has been repeated 3 times. So 4, 5, 6. That is 4, 5, 6. So 4 plus 5 plus 6 divide by 3. 4 plus 5 plus 6 is 15. Divide by 3 is 5. So you will be assigning 5 rank to all the 3 values. 30 observations 3 times. You will be assigning 5 to all of them. Now 4, 5, 6 is over. Next is 7 for the 20 and 8 for the 10. So that way all your ranks are over. If you have any doubts or you didn't understand it properly, just replay the video and you will get what I am saying. Next is marks in dancing skill. The highest marks are 80. The next is 60. After 60 comes 40, that is the third rank. After 40 comes 28, that is the fourth rank. Now 20 and 20 has been repeated twice. That is the fifth rank and the sixth rank. So 5 plus 6 divide by 2. 5 plus 6 is 11. Divide by 2 is 5.5. Your ranks will be 5.5, 5.5 for the both of the observations, the same rank. If the observations are same, we can't give them any different rank. We have to give them the same rank. So 5th and 6th are done. Next is 7th given to the 15, and the last is 8th given to the 12. This way you get the Rx and the Ry columns. So once you are done with that, write down our D and D square columns. Find the differences of Rx and Ry columns. Positive, negative, doesn't matter. Make a square of the D column, and once you are done with the D square column, make a total of all the ranks, the D square column values. That way you get 81.5. Now write down the formula. In the formula you have to add the CF in the formula. Put the values. Now D square is 81.5 and CF is 2.5. So you just add both of them and that would give you 84. You multiply it with the 6, that would give you 504. Divided by 504 is 1. That means the R is 0. Here we can say that there is a lack of linear correlation. It just means that marks in economics and marks in dancing skill has no correlation, no linear correlation between them. In short, they are not related with each other in cause and effect relationship. Economics marks and dancing skill marks does not affect each other. They are totally separate skills. Your economics talent and dancing talent has no similarity. That's what this says. Now, 23rd question. There is an marketing electrical appliances agencies marketing these appliances, and they want to know the sales and profits of LED fittings. So sales data is given, the profit data is given, and we are supposed to calculate the rank correlation coefficient between these two things. Now, as you can see in the sales, the data is 25, 58, 215, 72, 58, 25, 90, 162. You can see that 58 has been repeated twice and 25 has also been repeated twice. Write down the 3 columns: repeated observations, number of times the observation is repeated, and m cube minus m upon 12. 25 has been repeated twice, so 2 cube minus 2 upon 12 is 0.5. 58 has been repeated twice, so 2 cube minus 2 upon 12 is 0.5. Then for the profit, as you can see, 65 has been repeated 3 times. So 3 cube minus 3 upon 12 is 2. When you make a total of all of these values, you will get the CF3. So the correction factor in this sum is the value 3. So this way you calculate the correction factor first and then you continue with your regular table in this sum. Write down the headings like this: sales is X, its rank is Rx, profit is Y, its rank is Ry. Write down the values of sales and the profit. Once you are done with that, we will give the ranks. For the sales, the first rank goes to 215. 1000 units we will just ignore. 215 is the first rank. Next is 162. The next is 90. Now after 90 comes 72. That is the fourth rank. After 72 comes 58, 58 two times. That is 5 and 6. So 5 plus 6 is 11. Divide by 2 is 5.5. So we will give 5.5, 5.5 rank to both the 58, 58 answers. Once we are done with that, we have 25, 25 two times. Now 5, 6 ranks are done. The next are 7 and 8 ranks. So again we will make an average. 7 plus 8 is 15. Divide by 2 is 7.5, 7.5. So this will be the rank column for the sales. Next we will go towards the profit. The highest profit is 500. The rank is 1. The next is 340. The rank is 2. The next is 220. The rank is 3. Next is 140. The rank is 4. Then comes 115. The rank is 5. The next is 65, 65, 65 three times. That would be 6, 7, 8. So 6 plus 7 plus 8 will give you 21. Divide by 3 will give you 7. So you will be giving the same rank 7 to all the three observations 65, 65 and 65. Once you are done with that, you have to move forward towards making your two columns D and D square. The D is the difference between the ranks. So find the difference between Rx and Ry. That would be something like this. After finding the differences, make a square. This is your square column, and once you are done with the D square column, make a total of the D and D square column. The D column should always be 0. Remember that D square is 6. Put that into our formula, the correction factor formula. That means you have to add CF into D square. The CF was 3. D square is 6. So 6 plus 3 9, and 9 6 are 54. Divide by 504. So it is 1 minus 0.1071. That would give you the answer 0.89. There is a high degree of positive correlation between the sales and the profits. So we can say that the sales and profits are quite correlated, positively correlated with each other. That means that increased sales will give you high profits. Moving on to some final sums. Illustration 24. Here the question is directly given in the values. Transport company wants to know the relation between driving experience and the number of accidents. Sum of squares of differences. It is something like this. The sum of squares of differences in the ranks, that is summation D square. The sum, that is summation, the difference, that is D, the square, that is square of ranks, that is summation D square, is given 126. We have to find the rank correlation. Now we have summation D square, but how many? That is 8 drivers. It is given in the question itself, the 8 drivers. So n is equal to 8. Write down the formula, put the values, multiply, divide, subtract, you get your answer. Negative 0.5. A moderate degree of negative correlation is there. That means driving experience and number of accidents. If the accidents are more, of course the driving experience will be bad. If the accidents are less, the driving experience will be better. A common sense question is there. Now this is a kind of a question which may come in 2 or 3 marks. This is a kind of question, we call it the correction question. In this question, the one of the observation is taken wrong and you have to correct it. Here the question is that from various schools of district, they were ranked based on their proficiency in sports and general knowledge. That means two data is there, sports ranks and general knowledge rank. The rank correlation was already found 0.2, but in the later it was found that the ranks of two attributes, the difference of the ranks of two attributes for one student was taken as 3 instead of 2. Here the 3 is the wrong value, 2 is the correct value. We were supposed to take the difference as 2, but as it happens we took it as 3. It's a very common mistake, anyone can do it. But after finding that we have made a mistake, we are supposed to correct the question. How will we do it? First, understand our formula here. So 0.2 is the answer, and we don't know what's the total of the ranks, but we know that there are 10 students, right? 10 students are taken. So n is equal to 10. So whatever values are available, we will use that to find the wrong total of the squares, because once we find the wrong total of the squares, we will deduct the wrong value and add the correct value. That way we will find the correct total of the squares. So whatever values we have right now, we are using that value. We will change the side. That way we get summation d square is equal to 0.8 into 990 upon 6, and that way we get summation d square as 132. Now this is the wrong value. This is not the correct value. This is the incorrect value. But difference is 2. It is taken as 3. So we will find the corrected one. The correct summation d square is equal to 132, that is the wrong value, minus the wrong d square plus the correct d square. It will be like 132 minus 3 square plus 2 square. That would be 132 minus 9, that is the wrong one, plus 4, that is 127. So the correct summation d square is 127. So to find the correct value of rank correlation coefficient, we will again use the same formula, but this time in the summation d square position, we will use 127. So 1 minus 6 into 127 upon 10 into 100 minus 1, that would be 1 minus 762 upon 990. That would be 1 minus 0.7697, that would be 0.2303. So the correct value of correlation, rank correlation, is 0.23. This is a kind of question which can come for the 3 marks. So here our illustrations for the whole chapter are over. The last theory portion for this, we will check it out, the merits and the limitations of Spearman's rank correlation method. The merits for this method: the first one, that it is easy to understand. The second, that the calculation is easier than the Carl-Pearson's method. The third one, that it is the only method which can be used for qualitative data. The scatter diagram method, the Carl-Pearson method, both were only for the quantitative data. This is the only which can be used for qualitative data. The fourth one is that dispersion. If the dispersion is very high, when we can't use the data directly, this is the only method which gives the better result than the Carl-Pearson's formula. The limitations. First one, the ranks are used rather than the actual observations. So naturally, when we convert the data into ranks, there is a loss of information. The data gives us accurate information. The ranks does not give us the accurate information, and due to the loss of information, this method does not provide accurate value of the correlation. Rather than it's more like an average or estimate of the answer. Unless ranks are given, that means if the ranks are not directly given, it is actually difficult to convert our regular data into ranks. You know, we have to find the highest value, then we have to find the average for the tied observations, and then we have to find the correction factor and all that. So in the case where ranks are not available, we have to convert our data into ranks. It's a long method, and this cannot be used for bivariate frequency distribution. Carl-Pearson's method is used, and you will learn it in your higher study. The bivariate frequency distributions are there. In the future, you will see it. For that, Carl-Pearson is the only option. You can't use rank correlation coefficient for that. So here our today's tutorial is over. Your homework is all the illustrations twice of this tutorial, and learn the theory properly, write it down in your notebook to remember it. Next time we will be studying the exercise textbook 2.3 with the solution. So my dear friends, see you then, see you soon. Keep on studying, Stay home, stay safe.